All right, well, thank you very much, Scott. I appreciate it. There's a big picture of me. I hope everyone's enjoying the event so far. Some unbelievable talks. More to come later. So, yeah, here's my little segment. For those of you that don't know me, I'm Adam Sroka, CEO and co-founder of a company called Hypercube, and I'm going to be talking about my favourite topic today. My two favourite topics: large energy projects and large language models. So I'll take a whirlwind tour of some of the stuff that we're up to at Hypercube. Now, please, any questions, let me know or fire them in the chat, and I'll do endeavour to answer them. So, who are we? We are Hypercube Consulting. As said, I am based in gloomy Edinburgh today. We are the UK's leading data and AI consultancy for the energy sector. So, unlike a lot of other tech consultancies, we only really work in energy and do energy projects. We have lots of interesting partnerships. We have expanded into the US and we're looking at coming into the EU this year. And I would say our specialism is really bringing a lot of like deep domain expertise to energy sector projects that focus on data and AI. I grew up as a data scientist and spotted that the energy sector was a little bit backwards and there was a lot of data hungry use cases coming for it. So I thought I would jump ship and see if I could help accelerate the transition and net zero and climate change via my data and AI skills. It's a really interesting space if you're not familiar with it because there's lots of crunchy like hardware, there's geography to deal with, there's physical constraints, and there's a lot of financial like modeling and stuff that goes on. So if you like lots of data, IoT, finance, time series, it's really, really good fun. So today we're going to be talking about one of the products that we are launching from Hypercube, which has a code name Jellyfish, which made its way onto the talk. So that was me trying to come up with a dumb name to make it sound stupid. And we haven't given it a better name since, so it answers our postcard. But effectively, it's an agentic AI platform for large energy infrastructure. Why energy infrastructure? Well, here's a big number. The 2025 estimated global spend on energy infrastructure is set to tip just over 3.3 trillion US dollars. That is a bonkers number. It's estimated that $150 trillion will need to be spent globally in the next 15 to 20 years to build all of the infrastructure that we need to meet net zero targets. That's such an eye-watering sum of money. For those of you that aren't familiar, like even a small onshore wind farm that is producing several, maybe 100, 200 sort of megawatts of power can cost north of $500 million, like a lot of money. And they take a long time to build. This is an industry that's getting busier, it's getting more competitive. Competitive is not really the right word. There's more people entering the space. It's becoming more attractive from large capital expenditure. And there's a lot of things to manage, but to illustrate some of that, some of the timeline, so I talked about that's a huge number, right? Global spend. It takes about 10 years to build like an offshore wind farm. So take an offshore wind farm, but there's similar kind of timescales apply to things like big oil rigs or like onshore wind. They kind of vary a little bit, but illustrative for an offshore wind farm, there's these several stages. You do origination, where you try and organize the capital and kind of the consenting and stuff for this kind of project to go ahead. You then find sites. You then go into site survey and design, and this can take years because of things like ecological constraints and like local network infrastructure and things like that. You can't plonk a wind farm anywhere, right? It has to be able to connect to the grid and deliver its power somewhere. And these are really constrained high voltage systems that take years to move the right people, skills, and hardware to connect things up, right? But if you get your survey designed, you get through planning permission, all the local authorities, like all that, you get to what's called offtake and consent award. It's going to take a year. This is like a financial exercise where you're dealing with the like lawyers and how this thing's going to make money and banks and so on and so forth. Eventually, you get to financial close, which can take another year. This is saying, right, actually, I've got a wind farm site, I've got all the planning. I am going to make over 30, 40 years, I'm going to make a profit. So, can I raise $500 million to go and build the thing? And you get a big fat yes, and you're really happy. And then you go into the construction phase. You've spent like 8 years almost, and you've not done anything. You've not even put a shovel in the ground. And then this number varies anywhere from kind of 3 to 7 years it takes to build these things, depending on the scale, where they are, how hard it is to get to parts. So you can get like, or these are average numbers from Europe and UK. We're looking at 12 years before you've turned the thing on, right? And then you get 20, 30 years out of the lifetime of these, and hopefully you reap all the benefits and all that money back. This is a complicated process, lots of people involved. We are working with one organisation that are building an onshore wind farm. They've got 120 people. They're all finance, accountant, and project manager types, right? Working with them and others in the space, we came across another company that were building large batteries, and they said that actually there was one point in their project where if one of them left, they would shut the whole thing down. It wouldn't be worth pursuing because the whole project was kind of in her head, and it was all like she was so pivotal that it would have been so hard to unpick what she was doing that they'd have ground to a halt, right? And they were talking to us because they wanted to scale from doing 2 projects a year to doing 12, and they just thought we don't understand how this was possible. And at one point, they said to me, "We are dealing with millions of words spread across thousands of documents written by hundreds of people across dozens of companies." You just think, right, you've got planning, you've got ecology, you've got logistics and supply chain, you've got to talk to banks, talk to lawyers, talk to local landowners. Like all of these things, there's lots of parties, cross company boundaries, it gets really messy. And we're actually still using like tools developed in the 80s, like PDFs, emails, and things like that, like phone calls, rainbow colored spreadsheets to manage these things. Why? Well, first of all, no software specifically exists for this problem space. And secondly, computers were bad at this stuff until a few years ago, right? Like reading a 300-page commercial contract and making sense of it, or understanding meeting notes, or planning permissions and like planning consent forms and stuff. Computers just weren't good at this up until the advent of sort of large language models and the current hype train and things like that. So almost zero innovation in this multi-trillion-dollar industry like has happened in 4 years. So now's the time, right? And we've spotted this. So we think with some initial pilots that we've done, there's enormous savings that could be made that would allow these groups of people to go a lot faster, be a lot more efficient, and do more interesting things with their time, and ultimately make the cost of developing a wind farm a little bit cheaper and more effective. So we get to net zero. That's why we're really excited about it. How does it work? So what is it? Well, effectively, the way we've built this and sort of knitted all this together is instead of trying to build like one big agent or one big piece of software to rule the whole thing, actually, we have gone down the route of really razor thin agents that are doing pretty simple tasks and bundling hundreds of them together in big long chains that map to the business processes of what the humans in these businesses are doing. And so in our initial funding application, when we were looking at putting this together, one of our bids, we did a lot of research and worked with operations research teams and some of our customers, and we came up with this high level process that, and we just call it our change capture flow, right? And this is effectively on the bottom left, this is kind of pseudo business speak, some of this stuff. But at the bottom left, it basically says we will take every process, every data input to data output event that happens in that chain and map it like a great big graph. So what we're doing here is we're thinking every time there's a phone call, a document, there's some sort of form, there's some sort of permission occurs across the development of this wind farm, we want to capture, well, what were the inputs, what were the actions, and what were the outputs? And this has taken a long time to do for a very thin sliver across one of these projects because they are very complicated. But the beauty of this approach and the way you can model things in this way is you can build really thin layers aligned to a single use case. You pick one stakeholder in the business and you master what they're doing, and you try and deeply understand the way they're that thread works, and then you can layer more and more on top. And then all we do is we basically have this process that says every time an element is updated, an element in our graph is updated, new data comes in, we have an integration layer that pulls that in. That is MCP based these days. So we started this about 8 months ago, but that's MCP based now. And actually, a lot of the work we do is actually cemented in SharePoint and things like that. These organizations are very Microsoft Office based. So it's quite nice. There's not hundreds of systems we need to integrate with. There's not really complicated things. Microsoft, it's SharePoint, it's Excel, it's PowerPoints and PDFs, right? Outlooks and email. So a new email comes in with a new PDF that's an update to a contract. We have an integration layer, an agent that understands that event has occurred, spots it is relevant and classifies that it is relevant to something on our chain, our graph of events that are relevant to the project. We detect the change. We use large language models to parse the object and understand what was in it, what was the nature of it. Was it a transcript from a call? Was it an angry email? Was it an update to a cell in a spreadsheet? Then we classify that change. And in the initial stages of this, we are still using a lot of very human in the loop until this classification agent, or agents are a kind of catch-all term for a few systems here, but so it's akin to a recommendation system. Like, I believe this element this data change affects this element. But effectively, until that gets to a very high level of confidence, like north of 90%, we are keeping a human approval gate here to say, yeah, okay, that does affect that. When that is up and running and in the pilot we've got there to where this happens, then that becomes an autonomous thing where it can do all this automatically. It then updates the element that's downstream of it in the graph based on what we've mapped, and it cascades changes through the graph, right? Saying that, okay, if I update, that email comes in, I need to update that spreadsheet. Well, if I change a value in a spreadsheet, then that has a knock-on effect to actually this Gantt chart that now needs updated. So I'll go and or another element that like agent will come along and change that. And again, every element, we're mapping one agent to it that really understands what's going on in that business process, has all the context, has all the rules, has all the evals to do a really good job of that one bit. And we just chain hundreds of these things together. That cascades through the graph. Again, we are recommending changes at this stage because we want to get this right. We don't want to confuse or delay these projects, and this is still under development. And then, if necessary, we'll get to the point where this is recommending new actions or things that a human might do that haven't been automated into the graph of changes and business processes. And recommend to the human, again, that human in the loop element, they can act on it or not. How are we coming up with this graph? Good old-fashioned consulting, business analysis, just deeply understanding what the customer does, talking to them, working through their problem. What's the architecture of that look like? The architecture of that is probably fairly straightforward. I hope that's large enough for everyone to see. On the left, we have a load of systems, right? Emails, spreadsheets, the kind of stuff I've talked about. We have an integration layer, so depending on whatever the context is, we have MTP, we have SFTP servers. Sometimes we've got like subscriptions to topics, so on and so forth. And then we build a pretty basic data platform that can understand and process them. And then we have this sort of overarching orchestrator that does a lot of the job of calling the change data capture flow process, the action fulfillment library, so which agents do I call, and then a huge library of agents for it to work on. And then it will move on to autonomous or semi-autonomous downstream actions, as you can see on the right, which may call on other integration layers and sort of go back around the loop, right? We are in the early stages of designing UIs for this thing, but most of our customers in this pilot stage are really fond of just like a simple Streamlit or Chainlit ChatGPT type interface where they can talk to what's going on. But the majority of the interface actually ends up being emails, spreadsheets, like it's in the office tools that they're using day to day. One of the things to say about this that is quite challenging is permissions and how permissions cascade. So we're really focused on Azure at the moment, directory and things like that, because Again, that is a hard problem to crack. We don't want to have data leakage across division boundaries or things that shouldn't be happening. And so we there's some good solutions out there, but we are super cautious that some of the data in this space is really, really sensitive. So we're just being extra cautious at the moment in that stage of our development. I'll rattle through this. You'll probably know all this stuff, but this is effectively like how does that all thread together from a kind of workflow point of view? And effectively, so the example I like to use here, my wife's an ecologist, right? So if you're in the UK and you want to go and build a wind farm or build a big battery or site or a gas power station or something, you have to get an ecologist to come along and check that there's no bats or badgers in the region, and if there are, you have to move them, right? And so for bats, they can only be surveyed up until the end of September. And so imagine we're the last week in September, your bat survey is scheduled. And once that's approved, you can move to the next stage of the planning process, right? Well, my wife shows up or your ecological consultant shows up and phones you up in night time because it's late and they have to do this at night. Oh, by the way, it's raining, we can't do the survey, so it's been cancelled. And actually, it's the end of the bat season, so we can't do the next survey till March. That phone call, unbeknownst to the ecologist, has just created a 6-month delay to revenue on a £600 million project, right? And actually, what if that phone call, that email, or however it comes through, lands in the inbox of someone who's on holiday, or someone who's not available, or someone who doesn't understand how important that is? That is like a kind of category 1 red alert problem. You need to find another route, someone that can do the survey outside the normal window as soon as possible, because this is on the critical path for the whole project, right? So that email comes in, and effectively into an end user application like Outlook. Well, we have a monitoring service, and you'll see it's called Tesseract here. We kind of switched from Jellyfish to Tesseract at one point. We still aren't settled on a name. The monitoring service detects that some data has come into the system and it affects an element on the graph, right? We have the orchestrator agent is then responsible for calling the library of agents that are relevant, and it goes through, finds task specific, does the processing. It then might do things like check the contract for process slippage penalties with the ecology consultancy. It might also update the critical path on a Gantt chart in a separate work stream. It might also write an executive report to say this has happened, so that when the CEO comes in the morning, his hair's on fire, he has a good understanding of what's there. Then it sends the prompt, all the context, all the stuff it needs onto the foundational services like Claude or Gemini, we're quite fond of. And then that sends the response back to the agent, which will do the job of processing it to the downstream actions and so on and so forth. Finally, the end user is alerted within the workflow to approve or refine what came out of this setup, right? And that, once you've built all that, there's some really clever, fun things you can do with it, like chat with the project. Like a lot of these wind farms, for example, have really significant impact on local government, so they have to answer lots of questions to local government. Well, actually, we've proven that you can load all the context of the latest status of the project into a portal and give local government access to that. You can do things like automatically update financial reports, speak to your bankers, and so on and so forth. It's proving to be a really useful, a really valuable tool to a lot of the pilot customers, and we're really excited by it. So that's me for now. I've got time for questions, I think. I just want to say, if anyone wants to hear a bit more about what we do, or is keen on looking at how do you build these kinds of business cases, then we have a guide that we wrote. There's a QR code here, but I can share that. You'll find us at wearehypercube.com. I'd love to nerd out about this stuff or what you're up to. And thank you very much for your time today.
Awesome. Thank you so much. That was great. This whole time I was watching this, I was like, when are you going to like release this to manage my life? I was just thinking about all the times that it just like, oh, this thing changed and now I got to go update all of these other things. And usually I just don't do it.
Yeah. And the thing is, and so go back to the big 3 trillion number, right? Like when your project is a $600 million wind farm, that little delay is actually really valuable. So it's worth investing the time. And the beauty of this space is wind farm developers, for example, they're non-competitive. None of them, I don't care if you build your wind farm faster than me. I just want to build mine fast. So they're quite happy to share data, insights, and therefore, as a product, it will learn and get better. The big challenge is mapping like a kind of standard for all of the processes that go into it. That's the real tricky bit. But the actual tech and the agents, they're pretty simple.
Yeah, totally. Cool. We have one question in the chat. And I think the best way to ask this is, do you see any sort of irony in the fact that you're using agents and LLMs in the energy industry, given how much energy these AI systems tend to use?
Yeah, no, good question. Ultimately, I think they use a lot less energy than a project manager driving to an office in a diesel vehicle and doing all this manual right? Like it is right, and these things are wasteful. But I think they'll only get more efficient, first of all, and secondly, if it's to drive down the cost of building green energy infrastructure, then that's how I sleep at night. Like, that's how I justify it to myself. But no, I understand the debate around the cost of large language models. I actually think the Stargate project, or whatever it's called in the States, like 500 billion. Like when that came out, I said like 30% plus of that budget will have to be energy infrastructure, because basically the main input to a data center is how much power it's going to use and where it's going to get that power from. So it'd be interesting to see how much new energy infrastructure pops up across China, the US, simply to support these new data centers for AI and large language models.
Totally. So given we have a few minutes left, what do you think is next for Hypercube's journey into applying AI in this industry?
Yeah, we're doing some other stuff. The other really fun project we're building is a compliance automation tool. So testing like for big, large enterprises that can't do, we like a couple of enterprise customers that bumped into the problem of they literally can't approve any large language models because it's too scary from a governance process. Like there's no one to tread the path yet. How do you get legal and InfoSec and IT and cyber and compliance and data protection just to go, yeah, all right, fine, let GPT loose on all our customers' data.
Yeah.
So we're actually building a tool to do testing and automation of compliance processes as well. That's been really fun because we're doing like live monitoring of the latest prompt injection attacks, bias detection, all this stuff. Like, is my energy company public-facing chatbot teaching people how to make bombs and like poison each other and all this stuff? It's that's been a really good fun project, and we're learning more and more as we go, but it moves at lightning pace.
Totally. Awesome. Well, thank you for your time. We'll have to catch up again soon. Would love to hear about what else you've been up to. But yeah, with that being said, take care, Adam.